need to do is write it in standard form. It's not, so we move all the terms to one side. We'll add 2 to both sides here. Once you get to this step, you see that A is your leading coefficient 5, B is your first degree terms coefficient 16, and C is your constant 2. Okay, so when you look at those, what you can now do is plug them directly into the quadratic formula. And when you do that, you get x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so there's your numbers plugged in. We can go ahead and simplify what we have. Okay, if you square 16, it gives you 256. Here, 5 and 2 is 10, times the negative 4 is minus 40. 2 times 5 is 10. So as we continue to simplify this, we get negative 16 plus or minus the square root of 216 over 10. We can continue to simplify our radical. You may need to use a calculator again to kind of help simplify that, but you wind up with factor of 36. That gives you 6 with 6 remaining left inside, and that's all over 10. And so now when you look to simplify your numbers, you have to look at all 3 of these locations. Are there any common factors between all 3 of those numbers? 2. 2 goes into negative 16 8 times, into 6 3 times, and into 10 5 times. So your solution is negative 8 plus or minus 3 root 6 all over 5. And that would be your solution. Okay, so you can kind of see here, it's numbers that are not all that easy to work with. Okay. My recommendation, if you had a problem like this, even though it gives you uncomfortable fractions, you can still solve it by completing the square, in my opinion, easier and without a calculator compared to quadratic formula. So let's take a look at that here really quickly. So we have 5x squared plus 16x equals negative 2. Our constant is already isolated. So what I'm going to do is I'm going to divide each of these terms by 5. And that gives me x squared plus 16 over 5x, leave a space to complete the square, is equal to negative 2/5. When I complete the square here, I'm going to take half of 16/5. So think about what that means. If I take 16/5 times 1/2, the 2 and the 16 reduce to an 8 over 5. So I get 8 over 5. I'm going to square that. I'm going to add 8 squared over 5 squared to both sides of this equation. On the left side, I can rewrite this as a binomial square x, and then it was the value that I squared here, 8/5, half of this middle term's coefficient. So plus 8 over 5 squared is equal to my denominators in this, this was a 25 here. So my denominators need to be the same. So in order for me to combine these into one single denominator, it's going to be 25. 2/5, what do I have to multiply top and bottom by to get a denominator of 25? 5. 5 times negative 2 is negative 10. So I take negative 10 plus 64 is 54 over 25. And now I can extract my square root, leaving x plus 8 over 5 equals plus or minus the square root of 54 over the square root of 25, which is 5. Subtract 8/5 from both sides, plus or minus. What perfect square factors can you remove from 54? 9 times 6. The square root of 9 comes out as a 3. 6 stays inside. And so notice here you get negative 8 plus or minus 3 root 6 all over 5. So it gives you smaller numbers, easier to do mental calculations with if you do not have access to a calculator. Not a bad way to approach a problem like that. All right, if we take a look at this last problem, again, I'll go through the steps of quadratic formula. Okay, first thing we do is we rearrange our terms. We have to subtract this 40x from both sides plus 22. And that's equal to 0. Okay, can we simplify this in any way? What common factor can we take out of each of these? So if we want to, we can simplify this so that we get slightly smaller numbers. Okay, and we can work through our problem from here. So we have our standard form. X is equal to negative b. Let's look at our a is 8, b is negative 20, and c is 11. So we get negative b, so negative a negative 20 plus or minus the square root of negative 20 squared minus 4 times a times c, and that's all over 2a. As I look to simplify this, a minus and a minus gives me a positive 20 plus or minus. When I take these values, negative 200 squared is negative 400. If you take 4 times 8 times 11, you get 352. That's all over 16. Continue to simplify this. 20 plus or minus 400 minus 352 leaves you with 48. All over 16. And as you continue to simplify, you look to see, are there any perfect square factors of 48? Yeah, 16. The square root of 16 comes out as a 4, and it leaves a 3 inside the radical, all over 16. And so the last step here is to look at all three of these numbers. Are there any common factors between those three? Yeah, a 4. 4 goes into 25 times. 4 goes into 4 once. 4 goes into 16 4 times. So you get 5 plus or minus root 3 all over 4, and that is your solution.